Hi, my name is Chris Vernon. I'm the Vice President of Marketing and Product Management for Jacobsen. We'd like to thank TurfNet for the opportunity to talk to you today about quality of cut. Today you're going to hear from folks in engineering, operations, and product management about what goes into making Jacobsen's legendary quality of cut. Ever since the 1920s, when Oscar Jacobsen developed the first PGM, Jacobsen has been focused on developing excellent turf conditions for our customers. In fact, the engineering design that he put in the 20s is still roughly the same as what we produce today. So the first person we're going to hear from today is Lynn Westbrook in engineering, and he's going to tell you what goes into designing the optimum quality of cut.
Hello, I'm Lynn Westbrook, Principal Engineer at Jacobsen Textron. We're here today on the dance floor at the World Headquarters in Charlotte, North Carolina. We're here to discuss the configuration of our 5-inch reel that's basically an evolution of the reel that was designed with a walking greens mower in 1921. In 1921, those basic configurations and geometry were used as we went to the riding greens kings that we used in 1968. The basic configurations have stayed much the same. This is one of the very first riding greens mowers, and it was called the Greens King. That same reel configuration went forward into the fairway designs that we used in 1988 with a unit we called the LF100, or a light fairway mower. Much has changed since 1921, but one of the things that's remained the same is the basic design of the reel. As we look over here, on the Eclipse 2, we got electric drive, variable frequency, gone from mechanical through hydraulic and now into electric drives. The basic system is the same. The engineers got it correct in '68, and we're still using that same configuration today. Evolving into the riding unit with Eclipse 322 is a product we have here to my immediate left, and we're using those on greens today, and with variable frequency of cut and efficient electric operation. Now we will need to go and take a closer look at the configuration reels and getting inside the design of the product. We just came from the dance floor, and we have taken a reel assembly and we've cut the ends away so that you can look inside the unit. As you see, we have the reel blades, bed knife, front and rear rollers. The placement of these components is critical to follow contours well and give a consistent height of cut. Front roller placement, distance between the rollers to the center line of the reel are very important to maintain good quality cut. Important components, we have a bed knife and the reel blades. These are what are the shear edge and give us our cut that we need. The rest of these components are important, but again, this is our action area. The bed knife needs to be ground so that the top surface, the front corner hits the blade first, so we make sure we shear on the front corner to the blade so we get an efficient cut. We also come into rake angle. Typically the more rake angle that we have gives us a little bit of a vacuum effect across the tip of the blade. As you get into fairway reels, we have a little bit more rake angle. Our greens reels are pretty straight up, so you'll see this angle come back and these blades are straighter. We have the distance behind center. This unit is showing distance behind center of being significant. We also have ahead of center configurations. If you can picture this reel cutting turf, this being ahead of center and this being parallel to the ground, you can see that the reel blade is above the height of cut, so you won't have as aggressive action of your cut. When they're behind center, this reel blade is actually into the turf and it'll rake across the corner of the bed knife. And then we have on center, which is not a normal condition, but when we have this configuration, picture the height of cut is right where the two come into mesh. Now there's different configurations as you take the same unit. Even with the one that's on center, as it goes down, it gets more aggressive because we get more reel into the cut, and we have different configuration lengths of bed knives to maintain proper aggressiveness in the cut. We've just been over the graphics that describes the reels, and now we want to show you on a unit on contact, no contact. We prefer a no contact method from 1 to 3 thousandths clearance on the reel. This optimizes our cut and allows us to require less power. Contact reel to bed knife uses less power, generates heat, degrades the edges, and just inhibits the performance of the machine and longevity. It's very important to think about this matter of energy use, whether it be a mechanical unit or a ground drive unit in any way, form, hydraulic, critical on an electric unit, because we want to be as efficient to get as many greens of cut as we possibly can. We moved away from ball bearings a while back because we could not maintain the radial stability of the reel as well as we would like. We moved to tapered roller bearings that's spring-loaded so that we can maintain a constant pressure on those tapers to keep the reel stable. In doing so, we can manage to keep our clearances controlled to take care of things. We've also got greasable bearings where we apply grease to the inner part of the bearing and drive the debris and moisture out of the bearings for better service life. All of this helps us maintain our quality of cut. Reel diameter is an important factor within the reel design as well. We have here a fairway reel. As you see, the blade space is pretty wide so we can get taller fairway grasses into the reel. It allows the tall grass to go in and feed between the reel and the bed knife. As we get into lower heights of cut, like we have on greens, we have as many as 15 blades, which is shorter grass, so we don't have to take as tall a blade stem into the reel to bed knife configuration. Some of the older units, very large diameter, again, not on refined turf. There were reels that Jacobsen built that were 10-inch, but they were more for mowing fields and pastures. We use a welded construction in our frame. We manage to keep the tolerances of frame together. They're very robust in the marketplace. They're welded here and here, both sides. We maintain parallelism on both sides, and that allows us to use our rear roller as our main point, which makes adjustment more simple by just using the front roller. Bolted together frames need to be adjusted for square and parallelism, and you have the difficulty of keeping the rollers adjusted front to rear. They have to be parallel. We have a baseline here. As we get into higher fairway heights, we put a larger roller on the front, which raises the reel to the higher heights. This is a 7-bladed reel. Getting a relief grind on a reel with this few blades in is really quite simple. Most any machine can do it. We had issues when we transitioned from 9-bladed reels to 11 with the processes we had in place at the time. We couldn't get as much relief grind on our 11-bladed reel as we did on our 9. Customers complained about bed knife life and a few other things. Through development and interaction with our manufacturing group, we came up with a new advanced grind process that allows us to put ample relief on all reel blades, and soon after that process was perfected, we came out with a 15-bladed reel with similar reliefs as we've had on our 11s and our 9s and our 7s. Now that we've gone over the details and geometry that makes our reels, let's go to the manufacturing facility and see how they are made.
My name is Kurt Aceta, manufacturing manager here at Jacobsen. What you see behind me is basically reel manufacturing. Reel manufacturing is like a small manufacturing plant, self-contained in a larger facility. This is basically where Jacobsen's history in design and engineering all come together to become real on the shop floor. No pun intended on the reel. What you see behind me is a robot where we're going to weld our spiders and our shafts together to become the basis of our reel cylinder. We're going to add blades to this as well, and then it's going to go through some other processes before it becomes a reel cylinder that you're going to use to cut grass. From that point, we also use other robots in order to hold dimensional consistency and quality to weld our real frames as well. And I'm going to show you that now. As I said, we utilize a robot to weld our real frames. This robot, which is affectionately known as the Thunderdome, is going to weld all of our real frames. Now, we weld our real frames versus bolt them together. For each lot that we run, we take one real frame and we send it over to our quality lab, where they're going to utilize a CMM to check its dimensional accuracy. With the robot, you're going to get consistency and quality with the robot. Once it comes out of the robot, we're going to move it over to our paint line, which is an inline paint line. But what I'm going to let you see right now is actually the robot running a real frame, basically welding it out. So. So what you've seen now is our real cylinder welding and our real frame welding. Now both of those are going to come directly into our powder coat cell. This is an inline paint system where we powder coat all of our parts. And unlike Henry Ford, you can have any color you want as long as it's black or orange. Now ultimately we powder coat because we want to have improved corrosion resistance. This whole area has been designed so that it focuses into our real grind and then into our real assembly area. Our next destination is to talk to our real grinding cell.
I'm John Whittington, Director of Manufacturing Operations here at Jacobsen. The area you see behind me is known as Jacobsen's True Area 51, also known as our real grinding department. Well, I'd love to spend the next 5 minutes talking to you about our machine grinding processes and our grinding machines themselves. I can't. See, the machines you see behind me were specifically designed and manufactured for Jacobsen's real grinding process. And it's because of the investment in these machines, along with the technology that accompanies them, we're able to achieve that superior quality of cut you see with every Jacobsen reel and that 45-degree relief angle. So after our cylinders go through a grinding process, they're all brought over here to our balancing machine. This balancing machine is very similar to that of a car tire balancer. What you'll see here is our operator, Derek, taking the reel cylinders that just were ground and placing them on our balancing machine. The reel itself will spin at about 1,000 RPM, and the computer system will show if the unit is balanced. It'll also tell if a weight is needed on the cylinder after it's been spun. As you can see here, this particular reel is perfectly balanced and does not need a weight. So you've had the opportunity to see our real manufacturing processes and our frame processes. But here's where the rubber meets the road. In this particular area, this is our real assembly area. This is where we make that superior cutting quality reel cutting machine. So this is Joe, our operator. What he's about to show you are all the quality checks that we do on our manufacturing line to ensure our true set reel cutting cylinders are superior quality. As you can see here, Joe is going to run a 2/1000 feeler gauge through the machine to set the unit for our cutting test. Now that he's got the bed knife to backing and cylinder at about 2/1000, what you're going to see him do here is a paper cut test, very similar to what our customers do in the field. What Joe is doing is spinning each individual blade, in this case a 15-bladed cylinder, at 5 points on the reel to check for cutting quality. Now that we passed the paper cut test, Joe is now going to test the true cut setting. What you see here, he's going to back out the knob 5 clicks, which will represent about 5 thousandths, before he runs a feeler gauge again back through the bed knife and reel. As you can see here, he's got the 5 thousandths feeler gauge. He runs that through, his ensured clearance. And now what he's going to do is another quality check. He's going to back that reel cylinder back in 5 clicks to get it back to that 2 thousandths. We will check for the 2 thousandths clearance yet again. And we'll also conduct another paper cut test again. It's because of these quality checks and the people that you've seen here today making our products that we're able to deliver you the most superior cutting quality products in the world. The Jacobsen True Cut Reel.
Hello, my name is Chris Fox. I'm a product manager here at Jacobsen. We spent some time today talking about the history of Jacobsen, starting with Oscar Jacobsen in 1921. We spent some time talking to our design engineering group and how we designed and engineered the quality of cut into our cutting unit. Then we took a look at our manufacturing processes there and understood how we ensure the quality there. Now let's take a minute to step out onto the turf and understand how that quality of cut transfers to you. I'm standing beside an Eclipse 122F that we've cut this green with here. Most superintendents will be able to look at the green and visually tell whether or not they have a good quality of cut. Let's take that one step further. Let's put a prism on the green, get down into the grass, and look at the quality of cut through the prism. So looking at this shot of the prism, you can see that there are very few stragglers in this shot. That means we've got a good quality of cut. We've got an even, smooth, consistent. There are very few stragglers that are going to cause friction or slow down the ball roll, and that's what we're looking for. You can also see that there's a very clean cut on the grass blade. In the second picture here, you'll see that there are more stragglers. These stragglers are going to create more friction, end up with less consistency on the green, and a slower ball roll. As you saw in the first shot of the prism, there were very few stragglers, but we also had a very clean cut on the grass blade. It's important to remember that we need both a sharp reel and a sharp bed knife to get a good quality of cut. If we have a dull bed knife or a dull reel, we tend to tear the grass, which will open it up to disease and insect pressure and jeopardize the quality or the health of the turf. Jacobsen, as we covered earlier in the engineering section, designed the reel with spring-loaded taper roller bearings, which allows us to minimize the contact when we set up the reel. By minimizing that contact between the bed knife and the reel, we can maintain a sharper edge longer, which will help you give you that better quality of cut, that clean cut on the grass blade for a longer period of time. So one of the other key things on the takeaway of the fewer stragglers in that prism picture is FOC. Just to be clear, FOC is a measure of distance. So it's how far the bed knife travels between the reel passing over it in one position and the next reel blade passing over it at the same point on the bed knife. So the way to think about that is with an FOC, frequency of clip, of 200 thousandths, in 1 inch you're making 5 cuts. With an FOC of 100 thousandths, in 1 inch you're making 10 cuts. You're literally making twice as many cuts in the same distance. So that's a key thing to understand, and it's one of the things that Jacobsen has brought to the table in the last few years. It's another tool that superintendents have to use to maintain the health of their turf and to get a better quality of cut. Originally, when we introduced this, most superintendents were looking at it as a way to increase their ball speed. So while maintaining a height of cut of 110, they were lowering their frequency of clip that was allowing them to get more ball roll. What we're seeing now, though, is superintendents are actually lowering the frequency of clip and raising their height of cut. So they are lowering their ball roll with the frequency of clip, but then bringing their height of cut up and slowing it down a little bit more. But what this is, it's allowing them to do is maintain their ball roll, but have a higher height of cut, and have a healthier stand of turf. This is going to allow them to need less fertilizer, less water, but overall give them a healthier stand of turf. And from a quality of cut, it's the quality of turf that we're looking at. So this is a key feature that Jacobsen has brought to the table in the last couple of years that we're still exploring and superintendents are learning how to use to their benefit. I'd like to quickly show you how easy it is to change it on a Jacobsen Eclipse 2 or Eclipse 322. Simply by inputting a passcode into the LCD controller here with the buttons here, I can then use the buttons to scroll over to my FOC. I hit enter, and now I can either scroll down or up on my FOC, which gives me the ability to change my FOC from anywhere from 0.086 up to 0.164, and this will vary depending on the number of blades you have in your reel, but it's a very quick and easy adjustment that gives you as a superintendent one more tool, one more knob to turn to control the health and quality of your turf. So that wraps up our presentation today on the quality of cut. We've talked a little bit about our history dating back to 1921 with Oscar Jacobsen. We've talked about our design and engineering and how we build quality into the unit. We've gone through our manufacturing processes and how we ensure quality, the cutting unit that gets to you. We've also taken a little bit of time to come out here on the green and take a look at how that quality of cut really translates to you as a customer. I'd like to thank you for your time today, and now I'll turn it back over to Peter for some Q&A.